Welcome again, grade 8 students. So today we're going to discuss counts the number of occurrences of an outcome in an experiment using table, tree diagram, systematic listing, and fundamental counting principle. So in this case, in our topic here, you will count the number of occurrences, or just simply you're going to get the number of outcomes from a certain experiment. So we have 4 ways: table, tree diagram, systematic listing, and fundamental counting principle. Those are the ways that you can use in counting the number of occurrences of an outcome in an experiment. So let's start. Tabular form. So tabular form is a way of organizing the sample points of an experiment using a table. So from here, from the word itself, tabular, you will use a table. So later on, we're going to give you an example of this so that you can be able to use that for counting the number of outcomes. Okay, so that's again the first one, tabular form. Okay, next we have the tree diagram. From the word itself, tree. So meaning you're going to use a tree. So later on you will see why is it called tree diagram. So it says there is a diagram that helps calculate the number of possible outcomes of an event or experiment in an organized way. So meaning tree diagram can be used for you to calculate the number of possible outcomes, to have an organized way of calculating the number of possible outcomes. Okay, next, we have the third one, which is the systematic listing. So, is a way of writing all the possible outcomes of a particular event or experiment. So, again, from the word itself, there's a system in listing. So, is a way of writing. Okay, so in this case, you were going to write all the possible outcomes of an event in a systematic way. So, later on, I'll be giving you an example of this one. Okay, and for the last one, we have the fundamental counting principle. So I'll be reading this. States that if one event can occur in m number of ways, and the second event can occur in n number of ways, and the third thing can occur in p number of ways, and so on, then the sequence of the things can be occurred in m times n times p, and so on. As long as you have different categories of these events, then you will just multiply it to its number of ways. So in this case, since you only have m, n, and p, you multiply that. But if you have m, n, p, q, r, just multiply those numbers of ways. Okay, next. Okay, let's have an example problem. So here's the problem. List all the possible outcomes and determine the number of outcomes when you toss a coin and roll a die. So in this case, you will toss a coin and you roll a die, and you need to get all or list all the possible outcomes and determine the number of outcomes. So from this problem, we can use the ones that we have said a while ago, the 4 types of, or the 4 ways in counting the number of outcomes. So let's start with the first one, which is using the tabular form. So as we all know, we are talking about tossing a coin and rolling a die. So here we have the die, and here we have the coin. You can actually interchange these two, but in our case, we're going to use coin here and die for the other row. Okay, so for the die, we have actually 6 faces, right? So we have 1, 2, 3, 4, 5, and 6. So that will be the first part of the table. How many or what are those possible outcomes for die? So we have 1, 2, 3, 4, 5, and 6. So those are the number of dots in a die. And for the coin, we only have 2 possible outcomes. Those are head and the tail. Now, just like when you are multiplying during your elementary days, you're using multiplication table. So it's like this one too, and like the Punnett square that you are using. Just simply combine these two from this part and this part. So this column and this row, just combine the two. So the first outcome would be head and then 1. So that's the first outcome. We have the head and 1. Next, head and then 2. So we have head 2 or H2. Next, head and then 3. So we have H3. Head and then 4. So we have head 4. Head and then 5. We have H5. And head then 6 will be H6. So these are all heads, and these are the number of dots in a die. Next, for the second part, we have tail and 1. So we have T1. Tail and 2, we have T2. Tail and 3, we have T3. Tail 4, so we have T4. Tail 5, T5. And tail 6 will be T6. So that's how you do a tabular form in counting the number of outcomes. So the question is, where is the number of outcomes? So this will be your number of outcomes. Just count it. Then you'll be able to know the total number of outcomes. So we have 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, and then 12. So therefore, we have 12 possible outcomes. Okay, next way. So again, to answer the question from tabular form, we have 12 possible outcomes. So there are 12 possible outcomes. Let's use another method, which is a systematic listing. So this is how you will do the systematic listing. It's just like the same as the table, but this time you're just going to list it. So it starts with H and combine it with the numbers of dots in a die. So H1, H2, H3, H4, H5, H6. Then proceed with T1, T2, T3, T4, T5, and T6. So therefore, the number of sample space is equal to 12. So that's how you deal with systematic listing. So you will use here the roster method. Next, using tree diagram. So in this case, from the word itself, tree, you should have a root, then you should have a branch, and also you have a fruit in there. So how are you going to use this one in getting the number of outcomes of that experiment when you toss a coin and rolling a die? So we all know that in a coin we have a head, and for a die we have here 6 faces of a die. So first is to connect the heads from the first dot here. So you call this one as the branch of the tree. This is the root, this is the branch, and this will be connected to the other one, then the answer here will be the fruit of the tree. Okay, then connect those for you to be able to form a tree. Okay, so we all know that this is the head part of the coin. So let's now combine the two. And by the way, for the coin, we have the tail, and we also have the 6 faces. So let's start with this one first. By the way, we have the branches again for the tail. So let's start with the first one. We have head and 1. So we have H1, head, and then 2 dots, H2, head, and 3 dots is H3, head, and 4 dots, we have H4, head, and 5 dots, H5, head, and 6 dots, so we have H6. For the tail, it's the same. Tail, and then this one will be T1, tail, and then 2 dots, T2, tail, and 3 dots, T3, tail, and 4 dots, T4, tail, and 5 dots, we have T5, tail, and 6 dots, we have T6. So, for you to be able to know the number of possible outcomes, just simply count the fruit of these 3. So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so therefore, we have 12 possible outcomes. Next, we have using the fundamental counting principle. So for the coin, we already know it that there are 2 ways, the head and the tail. For the die, again, we have 6 ways. So 1, 2, 3, 4, 5, and 6. So again, for the formula, M times N times P times Q and so on. But in our case, we only have 2 here. So we have the coin and the die. So for the coin, let's assign that as M ways. And for the die, let's assign that as P ways. So therefore, that would be 2 times 6. So therefore, you have 12 total possible outcomes. So that's it for fundamental counting principle. So let's have another problem. So what you can see in the picture. Okay, so here's the problem. As part of the celebration of the International Day of Mathematics in the division of Antipolo City, all schools in the division will conduct a poster making contest. The participant will only make 2-tone color poster. Each participant can only choose one from the primary colors. So these are the choices. We have red, blue, yellow. Again, that's for the primary. And one from the secondary colors, violet, green, and orange. So the question is, how many possible two-tone colors can be made? So the question is, how many possible two-tone colors of posters can be made from these 2 types of colors, which are the primary colors and secondary colors. So again, in solving problems like this one, always consider the categories for each ways. So in this case, we have primary colors and secondary colors. Okay, so next one will be using tabular form. So again, for the first column, we're going to use primary colors here. And for the second column, we have secondary colors. So for the secondary colors, again, we have violet, green, and orange. For the primary colors, we have red, blue, and yellow. Now, combining the two, So first part, we have red and then violet. So therefore, we have red, violet. Next, red and then green. So therefore, we have red, green. Next is red and then orange. So we have red, orange. Next row, we have blue, then violet. So blue, violet. Blue and then green. Blue and then orange. Next, third row, we have yellow and violet. Yellow and green. Then yellow and orange. So how many possible outcomes do we have? So just count in the number of possible outcomes. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So therefore, we have 9 possible outcomes. So that's for the tabular form. So let's proceed with the next method, which is the systematic listing. So again, you're just going to list it again. So starts with red and then combine it with the first secondary color, which is violet, then red again, then green, red, then orange. Then proceed with the second primary. We have blue, violet, blue, green, blue, orange, and next we have yellow, violet, yellow, green, then yellow, orange. So count everything here or every combination there. So therefore, you have the number of sample space which is equal to 9. Okay, next, using tree diagram. So let's start first with the primary color. So we have red, blue, and then yellow. Then draw the branches. So again, we have 3 secondary colors. So 3 branches for red and combine it with violet, green, and orange. Then next, we have for the blue, again, another 3 branches. So we have blue paired by violet, the green, and then orange. For the yellow, again, we have 3 branches again. So paired it with violet, green, orange. So let's now have the possible or the pairings of these colors. So we have red, then violet. That's the first one. Red and then green. Red, then orange. Blue, then violet. Blue and then green. Blue and then orange. For the yellow, we have yellow and violet. Yellow and green. Yellow and orange. So again, counting the possible outcomes or the possible two-tone color of posters. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So therefore, again, you have total possible outcomes which is equal to 9. Next. So next one, we have using fundamental counting principle. So primary colors, we have 3 ways. Again, that's red, blue, and then yellow. For secondary colors, again, we have 3 ways. Violet, green, and orange. So assigning again this using the formula m times n times p. So m ways and then p ways, we have 3 times 3. So therefore, that's equal to 9. So possible ways will be equal to 9. So the answer for the problem will be there are 9 possible two-tone color of posters. So that is the lesson for our probability. So again, thanks for watching, and again, see you to our next lesson. Bye!